Even though I haven't made use of an Atmel microcontroller in years, timers are timers. A USART is a USART at its core. A watchdog timer does what a watchdog timer does, and it's just the nitty-gritty details that separate the PIC16 peripherals from the tinyAVR peripherals. But one section of these tinyAVR microcontrollers that I've never had any experience with is the event system. I don't remember anything like it on the older Atmel microcontrollers, so I've either blocked it from my memory, maybe for a good reason, or it's something that's been added in the, years since I've used one. The feature list for events sounds great. One peripheral triggering another peripheral without the need for any software intervention sounds good. But there are some complications. There's always complications. I did have to think a bit about what would be a simple use case for this. Say I've got a short pulse coming from some sensor, and I need a nice long fixed-length output pulse, maybe to drive a solenoid or motor. As I haven't used a 555 timer since I can't remember when, I would take a small microcontroller, watch for an input transition, then start my output pulse and a timer, wait for the timer to expire, stop the output pulse, and then go back to watching for an input transition. All in all, works great, and the reason I hadn't used a 555 timer in ages. And it looks like this could be implemented with the event system in these microcontrollers. I've got a new ATtiny 402 project created in MPLabX and the MCC opened. I'll set the system clock up, going to set it to 2 MHz for right now. I would need to lower that if I wanted output pulses in the hundreds of millisecond range. But for viewing the outputs on the scope, this should be a good working clock speed. Configuration bits are left at default, interrupts are disabled, and if this works like I think it should, the only use for the CPU core will be in setting up the registers at the initialization. MCC will generate the main.c file. Since I don't have a sensor handy outputting a short pulse, I'm going to use the RTC module to emulate that. I'm going to use the scope to view the outputs from the microcontroller, so I'll set the RTC overflow value to 100 milliseconds. Should give me 10 events a second, just fast enough to look good on the scope. Again, we'll not be using any interrupts, so I will disable this. Now I will add the TCB0 module. With these clock settings, the maximum count time is around 32 milliseconds. Can divide the input clock by 2 and double that time, but for long output pulses would need to reduce the system clock. I'll set the timer to single shot mode. In this mode, it is a non-retriggerable one-shot timer. Then I'll set the output pulse width to, let's say, 10 milliseconds. I need to enable event input capture, otherwise it will just ignore the event being sent to it. And I need to enable the output pin. I'll let the initial state stay low. And now to add the event module. I'll move this tab over to the main panel area. It needs a whole window all to itself. This first section is the asynchronous channel 0 generators, and I'm going to use the RTC overflow event right now. It will only connect to a synchronous channel 0. The output of a synchronous channel 0 will connect to all the users listed except TCA0. TCA0 is a synchronous event user, and only the synchronous channel 0 will connect to it. And of course, I will connect it to TCB0. If I take a look at the pins grid, it doesn't show PA6 as being an output for the TCB0, but it is, and I have the scope's channel 1 connected to PA6. I'll generate the code and then program the device. And there we go. TCB0 is outputting a pulse on PA6, and it looks to be close to every 100 milliseconds. Let me take some quick measurements. Pulse width is right at 10 milliseconds, just like it should be. Off time is right at 90 milliseconds, so everything looks to be operating like it should be. I'll alter the pulse width just to make sure it is working like it's supposed to. I'll change it to a 15 millisecond pulse, generate and program the chip. Pulse looks wider. I'll pull up the measurements. Sure enough, right at 15 milliseconds. Let me take a closer look at the input event to the TCB timer. Quite a few input sources to choose from. More listed here than are available in this AT-Tiny 402 device. I have a push button switch connected to PA2, so I'm going to use that as an event for TCB0. I will set PA2 as an input and give it a name, SW1, though I won't be accessing it with any software. Again, generate the code and program the device. Let me set the scope to capture a single trace. And there it is, a single 15 millisecond pulse. But the trigger for the TCB module is not a level trigger, it is an edge trigger. So clicking this button is creating two edges. Here I push and hold down the button and no pulse. But when I let the button up, then the pulse is triggered. So it is a rising edge that triggers the timer with these settings. But a falling edge trigger is easy to achieve. On the Pins tab there is an Invert I/O checkbox. I'll check it, then generate the code and program the device. Scope is waiting for a signal. I'll push and hold the button, and now I get a pulse on the push of the button. A falling edge on the PA2 pin. Again, set the scope to wait for a signal, and release the button. And nothing, just like it should be. There are two modes for the edge event. The default is a single edge, a rising edge as the timer sees it. But if the edge event bit is set, then it will trigger on both a rising and falling edge. I have to click the button pretty quick to get both pulses on the screen. At least it seems pretty quick. Each trace across the screen should be half of a second. Of course, my trigger point is right around the midpoint of the 500 milliseconds. Anyway, the fastest I can push and release the button seems to be a little over 50 milliseconds. What if instead of a single pulse, I need a pulse of pulses? Well, this is where the event system is lacking a bit. The output of the TCB timer is not an event. The only event TCB generates is a pulse 1 peripheral clock period in length. I'm going to hook up channel 2 of the scope to the PA3 pin, which is the default output pin for TCA0 in this device. Going to need to display a bit more information about what is going on. So if I turn off the enable pin output for TCB0, is it still producing its signal? The timer is still enabled and running. Here I'm going to add the CCL module, the configurable custom logic block. This modules tab also needs a lot of space, so I will move it over to the main panel as well, and make as much vertical room as I can. I will connect TCB0's waveform output to an input of the LUT0 and connect LUT0's output to PA6, and then open the settings page for it. I need to enable the LUT module. The output is already enabled. Input 0 is the TCB0 source, and the other two inputs are mask off. The function is an AND gate with only one input, so just a buffer. I'll generate the code and program the chip. And there we go, I have my signal back. So the button to disable the TCB output only disconnects it from the output pin. It is still fully functional. Now I'm going to add the TCA0 module. I'm going to leave all the clock settings as they are for now. I will set the waveform mode to frequency generation mode, and set the output frequency to 2 kHz. I'm going to enable compare channel 0. It seems like if channel 0 is not enabled, channel 1 and channel 2 don't produce any signal. Not positive about that. I very well may be missing a setting somewhere. Let me bring up the pin grid. Can see that the pin output for TCA0 is connected to the Enable Channel 0 button. It turns out the Enable Channel 0 button is setting 2 registers. There really needs to be 2 separate buttons here. One to enable the compare channel, and another to enable the output pin override. Now after programming, I have the TCA0 waveform output 0 on PA3, scope channel 2. I will double check and make sure the frequency is correct. Let me pull the cursors up and get them set. Yes, right at 2 kHz, so that's good. Now back to the CCL tab. I will take the TCA0 waveform output 0 signal and connect it to an input of LUT0. The only input it will connect to is input 0. Fortunately, the TCB0 output will connect to input 1 of LUT0, so I'm still good to go. Taking a look at the settings here, I now have a 2-input AND gate. I'll generate and program again, and it looks like I have my pulses of pulses. Well, more like a pulse of 2 kHz square wave at this point. Now I think this is a bit of a quirk. If I turn off channel 0, now this is turning off the compare channel and the pin override. Of course, after every change, the code has to be generated and the microcontroller programmed. The 2 kHz output on PA3 is gone. The tiny bit of signal there is being picked up by the traces from PA6, but it's not 2 kHz. I'll expand the pulse and look at the frequency. It's right at 1 MHz, but it's not related to the counter timeout. It seems to be half the clock frequency. Just something to be aware of. Even with the compare channel off, there is still a signal getting to the CCL. I'll turn the compare channel back on. Now if I go to the TCA0.c file, the control B register has the bits that control the output pin override for the compare channels. So I will disable the output override for channel 0, program the chip, and now I have the 2 kHz signal in the pulse, and no output on PA3. Takes going outside the MCC, but not too bad. And there's really no reason for the waveform output to be sent to a pin. Now if I really want a pulse of pulses and not a pulse of square wave, I'll change the waveform mode to PWM. I'll set the duty cycle to 30%, and the PWM frequency is set from the timeout period. I'll set it to 200 microseconds. I think that will give me a 5 kHz PWM frequency. The higher the frequency, the lower the PWM resolution. I'll generate the code, but now that I have modified the MCC generated file, the MCC knows it, and I have to update what I want modified. I'll just update the entire file and program the chip. Of course, I have the PWM signal on PA3 again. I'll expand the waveform and get a good look at it. Right at 5 kHz and looks like a 30% on-time pulse, so just what it should be. I have to say, I like the event system. When I need a one-shot timer, I think I will reach for these instead of the PIC-12s I normally use. And it will be because of this event system. I know I've just barely touched the event system here, and I'm curious what are some of the peripherals some of you might use the event system for. Would love a comment on how you use the events. As for the overall tinyAVR family of microcontrollers, I would say the peripheral I miss the most from the PIC microcontrollers is the PPS, Peripheral Pin Select Module. It's not a big deal on 8-pin devices, but once you start getting a few more pins, having the PPS module does make laying out a PC board a lot easier. The port multiplexer in these tinyAVR devices offers a small amount of flexibility, but it's a far cry from the versatility of the PIC's PPS module. So I think that alone might deter me from using the larger pin variants of this family of microcontrollers. But for the small pin count variants, I like them. There will be more to come. Stay tuned. And thank you for watching.